Okay, welcome back everyone. As I promised, we have our first Linux version of ResUMES++. So, um, this is the software in Ubuntu, and then what I have for you is uh, I think it's like a compressed file, like an app image that you can just run, and all these dependencies are within that file, so you don't have to walk around with all these. So it's just one compressed file that you can execute. And I think in Ubuntu there is nothing else that you have to do, so there is no permissions that you have to attribute to that file. It will just run automatically as you double click on it, so it should be fine. So you just have to double click, and then it will open up just like the Windows version. Everything is the same. Just one note, because of course this is something we are developing. So as we are developing, we are adding stuff, and sometimes you can add something to your project, and it's working for a specific, not for a specific type of data, but it's only working when you are in a certain stage in processing your data. What I'm trying to say here is, if you ever have an issue with the software, remember you can always reach out. There are some information here that you can use: phone numbers, email address. So it's easy to reach out, especially with the email address, because phone number, I guess this is just for people who are in my country, right? So if you're not in Cameroon, you cannot use this. Well, maybe you can use this, but like, you'll have to reach out maybe through some social medias, but you can always reach out by email. Okay. So it works the same way. You will have to import the data, and you just have to remember where your data is. So I just have to go to home, my home directory. Then I think I'm going to go to documents. And from here, I think I need the folder name sections. In my case, this is just because I know where I can find the data that I need. So I can just try with this one. Click on open, and you will have this. Of course, now you have to define all those fields. You remember how I did it for the Windows version. Of course, it was in French, but yeah, now you have the English version. And this is where you have to pay attention, because if you do something wrong, then you will have uh, the wrong geometry for your data. I don't remember which one I was clicking. Okay, I'm clicking on this. The SP, of course, and the injected current, the measured VP. Once you're done, you close. And to check, you can, if you see this, it means that you have been able to import your data. If you don't see this, probably the software will shut down, right? If you can't import, I think it will shut down, because I didn't have an additional, I don't have an additional step here to check if the importation was successful or not. I think what will happen, if there was a problem, it will probably shut down, which is something I will have to address, because sometimes it's annoying. But just bear with me. This is the free software that we're developing, so I don't have a big team with me to check all this stuff. This is a one-man job. So yeah, if you ever have an issue, just reach out, okay? And then we work it out. So yeah, the from here, I think the next step is, well, you can go straight and then compute the variogram, but I'm curious about the histogram, the look, right? So it looks not exactly the same, but kind of the same with what I have in Windows. So you can export this, you remember, by clicking on this button, and you can save the histogram. It will ask you to save it somewhere, and you have this folder already where you can save it. This is the main folder. I mean, this is the root folder for your software. So your software is in this folder. So it's not a bad idea to save it, but something you can do is you can create a folder within this for this specific project. Maybe you have different projects that you're working on, right? Maybe you don't want to mix things up, so let me create something and call it P, or like just a project one, and then give a name for this. This is L1 and this is the histogram. So I'm gonna do this and save, and it's saved. And the next thing we want to do, I guess we can do it now, but normally you do it when you're done with you can do it now after the next thing. You may want to configure your neighborhood, and so you will use circles as a shape. You want a minimum number of points and a max just to make sure you don't grab everything. And you can set this one to, let's see, then the next one to I don't know, 40 maybe. And now the lag is the range in which you're looking for neighborhoods, right? And this shape is just like an example, like a visualization of that range. And since we're using circles, normally you can imagine there is a point here in the middle, and this is the radius of the circle that we're trying to draw. And then what ResUMES is doing is trying to grab all the points within that range. So that's what's happening here. And so this one as well, we can save it. Now we will save it in project one and we'll call it NBH1. You can save and it's done. The next thing now is, I guess we are ready to compute the program, so we can load or compute. Here you have the possibility to choose between the SP and the resistivity, so it depends on what you're doing. In this case, I'm just working with the resistivity. The reason why I'm doing this is because you have both, and most of the time you will have to use both to run your interpretations. SP are very important to understand mechanism. Like maybe you are in a region where there are so many complex structures, and you can use the natural responses to the electrical field to understand or to distinguish between different I would say formations or different geologies or different anomalies. So we use rho. This time we're not using the anisotropy, we don't need it. We will have to define a tolerance, of course. And once you're ready, you just hit the done button. And here we are. Here you don't have to worry about the least square because there was a time when I was using both, right? And what I noticed is for this one, you have to specify, or maybe you don't have, well, there are two options. For the least square approach, one option is to specify the model and then use the least square to determine the optimal parameters. The other option is to use the model as one parameter and then use the least square to determine the set of parameters. But when you want to use the type of model as one parameter for the least square, the algorithm is more complex because now you have two different types of data to manipulate within your algorithm. The first one is numerical data. The second one is like a cardinal data, like a categorical data, which is feasible, like I've done it, but it increases the complexity and sometimes it's not stable enough. So I decided just to go forward with the genetic algorithms because those are pretty much appropriate for all kind of, or not exactly all kind, but I would say almost all kind of stuff. So far, I still have to see something where I can't use genetics algorithm, because I've seen so many cases of optimization problems, and they all have somewhere at some point a setup where you can bring in genetic algorithms and it will work. The only problem is running time, memory issues, and also the quality of the result. So it's like it will work, but maybe there is something that you can use and have better result. Not better in terms of maybe accuracy, but better in terms of memory issues, for example, again, and running time, just like that. So yeah, just to say, feel free to only use this. And I think in this one, I'm not activating this just because I want to make sure people are not using something that, because I'm thinking about improving the least square approach with something else that I am not going to mention here, right? Because if you want to know more about it, then reach out. Maybe this is something we can collaborate on. But yeah, I'm not going to mention it here. So just use genetic algorithms. And we are using seal-based model. So you want to use spherical, exponential, Gaussian, and you're done. And you still have the possibility to change once you're done here. You still have the possibility to do this stuff. Like here, I can change this. This is power, but you see Gaussian because there is a switch between this. So this is 0, this is 1, this is 2, 3, 4, and instead of that it does 1, 2, 3, 4, 5. So yeah, the 4 is this one Gaussian, so it's fine. So you still have the ability to change here, and the way you can do it is you can click, maybe I want to change the range. It's going to change the range for me. And the last set of parameters that you have here is the one that ResUMES is going to use for the next steps. So if I click on this button, we are all set, which is what I'm going to do. And now you see when you come back, it's Gaussian here. It's just because of the numbering, so it's not a problem. I can fix that one as well. Okay, from here, what else do we have to do? I think at this point we have most of the information that we need to run. No, okay, there is a couple of configurations that I have to do. So I think now I have to configure the simulation, because I have the variogram model, I have the neighborhood, but the software needs to know if I want to run the SDS using Bayesian-based SDS or the frequencies-based SDS. The software needs to know if at some point I want to change the variogram model, if there is anything I want to do with it. And there are all the information that I'll have to pass to the software when I run this simulation. So those are also very pretty basic stuff to do. It's nothing really complicated. So I don't want to use the 1D parameters. I'm not going to talk about this one now. There's going to be another, maybe 1 or 2 videos where I discuss those. The resolution, again, this is something important. X and Y. My computer is going to cry about this. And this is what I was talking about. So this is an important step when you do sequential regression simulations, because in theory, like in the general principle of the SDS, after each simulation, you're supposed to be updating the conditional distribution, or the joint distribution of the conditional distribution. You're supposed to be updating the joint distribution of the data, which means you take the simulated point, you bring it to the conditioning data, and it's supposed to be changing the distribution of the conditioning data set. Now, if you imagine that you're changing that conditioning distribution, it means that normally the variogram model is supposed to be changing as well, because the variogram model is one information of that distribution. This is geostatistics. This is not just classical statistics, because if you think about it, when you have this type of data in classical statistics, the distribution is going to be, maybe if you're using the Gaussian, is going to be the mean and the variance or covariance matrix. But in this case, the variance or covariance matrix is built upon the variogram model. If you remember, you need a variogram model to have the Kriging matrix, and that Kriging matrix, one like one part of it is like a covariance matrix of the data. So if you remove those elements that we have in the, I think, the last 2 or 3 columns and rows, what the remaining part of the matrix is like a covariance matrix. So in this case, the variogram model has to change normally. But if the covering is good, so if the conditioning data that you have is covering, in a way, regularly covering the domain that you were sampling, and then if you think that there is very little chance to have something like quite unexpected after a simulation, then in this case you may want to change the variogram. Otherwise, it's not really necessary, because maybe you are in this situation where the features are going to you'll be able to see the features better, but their distributions is not going to change as the simulation is evolving, which means maybe you will have different values as you're simulating. But when you look at the whole thing, like when you look at the big picture, the distribution is, geostatistically speaking, is not going to change because of the way the data was sampled. And this is just something good about ERTs, because if you look at the grid that I was showing before this step, you will see those points are kind of regularly distributed in the domain and pretty much covering all the field. So this is a good point. So I don't have to change this. I don't have to. Maybe someone will say, well, I want to change to C, but you will do, and then you will see it's not really needed. The difference is really negligible. And here you can switch. I mean, you can decide if you want to use the frequencies in Bayesian, and I like Bayesian, so I'm going to go with it. And if you're ever thinking about changing, this is where you want to play. Maybe you want to change, and maybe between simulations you want to switch with this tool. This is very dangerous, so I'm not recommending to do this. So we were modeling the variogram. I'm going to stick with the variogram, and here you define the minimum layers count, which is like how many layers do you think you have in your domain? I think I have at least maybe 3, and maybe max value is 8. This is crazy number, but yeah. And this is also an important parameter, which is how many times do you want to redo a simulation. So if I'm simulating this point, how many times do you want me to redo it? Which means I'm simulating it now, then I'm done. Then how many times I want to do it again? In this case, I'm going to say just 1, because I don't want to do it a couple of times within the during the process, because this is just for demonstration. And when we're done, we click on the button again. We save here, because I'm gonna call this simulation config. Okay, save. Well done. Normally that's it. Normally I have everything. If I don't have everything, I will have an issue, but normally I have everything now. So I can hit on this button now. So when you hit on it, you have to go grab this guy, open, then Those are just the, so the first one was the histogram, which is again something also important just for comparison. When you're done with the simulation, you want to compare the distribution of the conditioning data, the distribution of the simulated data, just for comparison purposes. So you want to click on this and open it. This is I think that one was the simulation configuration that we did before we start the inversion. This is the neighborhood. And I think this one is like a logging file though. So this is the file where the software is going to save all the operations. So when you're done, if you think something went wrong, you can go inside that file and read like each line is going to be, I think, the result of a simulation. So you will have the coordinates and you will have the simulated value. And I think you will also have the variogram model, the stage of the variogram model for that simulated value. So you need to provide a name for this. And save. So now the software is going to simulate. Oh, pretty quick. I like that. So what you see here is also very, very, very important. Before simulating, I forgot to import the topography. So it means that when I'm going to click on the option where I can configure the layers, I won't be able to see the surface, the shape of the surface, because I don't have the topography imported in this file. I will show you how to do it when I'm done here, but yeah, just click OK because this is something we forgot. So it's just this one. I was supposed to come here and then add topography from the CSV file, and then it's supposed to be something like I have to go to documents, again sections, and ls topo, and I'm supposed to be loading a CSV. So this is L1 for the file that I was using. And one way to check if you have topography is here. If you click here and you see this, means that you have the topography file. And if you don't want to see it, you can just click here, it will remove it. So now this is something I forgot to do. So I'm not sure I'll be able to see the shape of the surface here, but it's fine. Just remember that if you do it before you run the inversion, then you have the possibility to see the topography on your resistivity cross section. So these two, so this is the histogram of the conditioning data, the imported data, and this is the histogram of the simulated data. Again, this is just for comparison. Here, this is just for visualizing the inputs, right? And here is to visualize the outputs. The outputs, you have three cross sections. One is the maximum likelihood cross section. So again, imagine you're doing a simulation using a Bayesian approach, right? And you will have a value, but you also have a credible interval. And so if you think about cross sections now, you will have three cross sections because you will have an estimate and you will have the upper and lower limits of your credible interval. So this is why you have three cross sections here. One is like the upper limit, the second one is like the lower limit, and the third one is the estimate. And this is where we are supposed to be using the topography. So this is our grid, and over here you have the possibility to determine the number of layers that you want manually or using equal interval with this guy, or you can use the well, this is something we will have to include in the software, right? I think this is we are still testing, so I can't share that one with you now, but you will have the option to bring a geology file from your survey, and what the software is going to do is the software will use the database within the software with the range of sensitivities within the software to, in a way, identify what you possibly have for this cross section. And now what will happen is you will have a suggestion and you will have to modify it. If you're fine with the suggested layer configuration, then it's fine. You will go forward with it. But if you're not, then you will have to adjust it to your convenience. So yes, this is just very simple, as I said. And this step is what was presented in the paper we published about the software. And yeah, if you're using it, oh yeah, one more thing, you can export this by clicking on this button. And let's go here, let's call it let's choose this folder. Actually, I think it will just save, yeah, automatically with different names. Yeah, it's saving. We know you're working. Come on. It's taking time because I think I did something pretty. I tried to grab some very like fine resolution for those images, so that I think that's why it's taking so much time. And normally we should have those pictures here. Yep, there we go. So you have the max, the mean, and the estimate. So this is the estimate, right? And that one is the max. This one is the max, and the next one is the mean. The size of this is fixed, but the next release will allow you to change the size of the exported picture, so that maybe you want to have something exactly like this. But I'm always saying, if you can screenshot and crop, like, feel free to do it, because most of the time that's what I'm doing. I screenshot and I crop, because sometimes you don't want a crazy large picture. I mean, I'm talking about the size, like 20 megabytes. You don't want something like that. So with a screenshot, it's always, you know, a very light file that you have in the end. And what else? I think that's it. This is just all you can this is all we have. So like this is all you can do for now with the software. And again, just remember, there's a lot in development. Like, this was working, but because we don't want to share something that we are still testing, we're still trying to improve, we are not really oh, I forgot to disable this button. We are not supposed to have this happening. Okay, so over here is where you will have to do, because the idea for this part is you can do the VES modeling. And the VES modeling is good because this is one of the easiest way to have an idea of how many layers you have in your region of interest. So you can do the VES modeling, and then you will have the number of layers. And so with this, you won't have to specify manually the number of layer when you configure the simulation. It will just grab the information from the VES model, and also you won't have to specify the resistivity for each layer. All those information are usually coming from the VES model. You can grab them and use them. So that's the idea. And then it's supposed to be very simple. So that's why I can talk about it now, because I know anyone interested in doing something like that can do that. So yeah, so this is what you're supposed to be doing here. And we have the software. We already have a module to do the VES modeling, But the thing is, we want to allow the user to do it here as well. So there is a like a third-party application that we can call from here to use and then do the VS. But we also want the user to be able to do it just here without calling an additional module. So yeah, we will see. Some people, they enjoy working just in one place, right? They don't want to be switching between tools. Some other, they like when they can open another tool beside this and maybe working independently, and then at some point maybe connect those two results. So yeah, so this is all I have for you now, guys. Any comments, any suggestion, or any feedbacks, very welcome. We would like to hear what you think about this. If you have something you want to suggest, maybe something that you think is missing and you want to see in the next release, please feel free to reach out. We will work on it. So I'll say see you next time.